Okay, hello everybody in Statistics for Linguists. Whether you be in 560 or 660, this is the final homework assignment for the semester, and should be the final video for the semester that I'll be making too. But I want to just walk you through homework 11, which is going to be due on Monday, not of next week, not in 3 days, but in 10 days. So Monday, December 20th by 5 p.m. I'll just mention, so I used to have, the way I used to structure this class is I used to have 10 homeworks and then a final exam. So this homework would function as the final exam. It kind of like wound up being a bit stressful as a final exam, so I just converted it into a homework. But that's why it looks a little bit different from the other like homeworks that we've done so far, including it has this Steve Harris cartoon about I'd find math even more interesting if we didn't have to do all that math. Yeah, so that one's for all you nerds out there. You know who you are. Anyways, this one might look a little daunting. It's 9 pages in length, including the cartoon page. I like to have cartoons on my exams, but it's more, there's 3 different data sets you have to work with and 3 different techniques, and it's kind of more about just describing how the data is structured than about what you have to do specifically. So it won't be as much work as it might seem when you first look at this thing, but it does involve a fair bit of detail, or attention to detail, I guess you would say. So the first problem set is multiple regression. So this addresses this data set, and these are all from research projects that I've worked on over the years. So this one is about nativeness. So this is a study in which listeners were asked to rate the nativeness of a set of single-word English stimuli produced by both English L1 and German L1 speakers. So the listeners were all native English speakers themselves, but they were split into 2 different groups. The groups differed. Maybe I can make this bigger. Oops, no. The groups differed and how the stimuli were presented to them. That was kind of the interesting research question of interest. So one group of listeners heard each word in audio format only, and the second group both heard and saw the word in orthographic form on a computer screen in front of them. And we wanted to know if that modality presentation format would make a difference in how they rated the nativeness of the people they heard speaking. So both groups of listeners rated the nativeness of the tokens they heard, with 0 representing an English native-like production and 6 representing a very unnative-like production. So 0 would be like, there's nothing different from the normal English pronunciation of this. That's why it's 0. So there's no difference there. And then 6 is the limit on the high end. So that would be very unnative-like. Both groups of listeners also got the opportunity to replay the stimulus token as many times as they wanted prior to entering their nativeness rating into the computer. So they would hear it, or they'd hear it and see it, and then they could either just give a rating, or they could say, play it again so I can get another sense of what that sounds like. Okay, so I've got all this information about what's in this data frame. As you can see, there's a large number of variables. There's a specific number for listeners. There's also an observation number here, which is just a unique number for each row. You don't have to worry about that one too much. So there's a specific unique ID number for a listener. There's 2 different listening conditions. There's either no word, which is audio only, and word, which is audio and orthographic presentation, so they could read the word while they were hearing it. And maybe this isn't the best set of labels to use here, but it's the one we got. So deal with it, as my best friend used to say in high school. All right, so trial is the trial number, just in order for each subject. Speaker is just a number for each speaker that they're hearing. Then also the native language of the speaker is speaker L1. The word presented on that trial, like house or loan or Bob or so on and so forth. These are the different native languages of the speakers, so on and so forth. CellX is the raw frequency count from the CellX database. So that could be a very large number in the case of house, or it could be a very small number, like in the case of goon. I guess this is before I moved to Canada, so people didn't talk about goons and hockey all that much. But I'll point out as well, in this data set, these are all consonant, vowel, consonant, 1-syllable words. So that's why they're relatively short. But we also got a variety of different frequencies out of them. And to kind of make that a little bit simpler for ourselves, we also boiled those frequency numbers, the raw frequency numbers, down into 3 groupings, where 3 basically represents high frequency, 2 is like mid frequency, like 139, and then 1 is low frequency, like 81. So yeah, that's basically, and they're a bit, the cutoffs there are kind of arbitrary, but just, that's the way we did it. So just so you know what that information represents. There's also familiarity, which is the familiarity rating for that word taken from the database that we've been playing around with for most of the semester. This is from Harold Byon's monomorphemic monosyllabic English words database. Then similarly, the number of neighbors, orthographic and phonological neighbors, and kind of the crucial fields for the modeling part of this is that there's a rating, nativeness rating, assigned to that token by the listener. So that's the last number here. So like 3, it's going to range from 0 to 6, right? So a lot of these are zeros, some are 1, so on and so forth. There's also right before it a number of what I'm calling agains, which are the number of times that the listeners or participants press the play this again button. Play it again, Sam. Or, you can think of that as number of repetitions after the initial presentation of the stimulus. So most of those are going to be 0. They just rated it right off the bat. But sometimes they listen to it more than once. For this one, they listen to it 3 times more. That's what that number represents. Okay, so here's what you have to do. For the audio only or no word listeners, run a multiple linear regression to determine which of the following factors had a significant effect on the nativeness ratings. So we have, we can look at word frequency in terms of the SELEX rating, which is this variable here. Familiarity, that number we borrowed from the Harold Byon database, and also the 2 different numbers of neighbors, the orthographic neighbors or the phonological neighbors. So determine which of those factors have a significant effect on that rating, and then provide the multiple regression equation predicting the nativeness score and state the amount of variance which is accounted for by this equation. So this equation, you can think of how do we write linear regression equations, right? That will tell you what sort of information you need to include in that. And this you can get from your analysis as well, the amount of variance which is accounted for by that equation. Okay, that's task 1A. Task 1B, same thing, same factors, different dependent measure. So you're just going to do this for the audio and orthographic word listeners. Actually, sorry, same dependent measure, same independent factors, different group of listeners. Sorry, that's audio and orthographic or the word listeners, which are down here. This is a very large data set, by the way, like these word guys down at the bottom. Yeah, if you can remember, there were a few of you who were trying to do means and standard deviations by hand at the beginning. You don't want to do that with 34,000 lines of data. So I'm glad that we've all learned how to not have to do it by hand by now, hopefully. And then optionally, there's a bonus task. You'll get bonus points on your grade for this, but there's a number of different bonuses for this homework, just kind of in general. But this first bonus is provide an interpretation for the fact that some factors are significant in one of the presentation conditions, but not the other. So how might the method of presenting stimuli affect the influence certain factors have on judgments of nativeness? So basically what this is saying is that when you run these 2 different regression analyses, you're going to get one set of significant effects here, and then you get a different set here. So basically, try to come up with an answer for why that's the case. How might the method of presenting stimuli affect those judgments of nativeness? Okay, task 2A, this is where you get the different dependent measure. So for the audio only or no word listeners, determine which of these 4 factors, again, has a significant effect on the number of times the listeners replay the tokens on each trial. So this is the agains number. This person down here at the bottom is just never playing it again. Some people do though, right? Whoops, if I can show them to you. So like this person has a few. The agains data point, that's your dependent measure here. Do that for the no word listeners for task 2A, same sort of thing. Provide the multiple regression equation, state the amount of variance, which is accounted for by the equation. Do these significant factors, once you've done this, do they differ at all from the equation you developed for task 1A? And if so, how? Also, I just want to make it clear that for task 1B, and I say do the same, I mean, do this part of the task, determine which of the following factors are significant, and then also this part 2, provide the multiple regression equation for the nativeness score, and then also the amount of variance, which is accounted for by that equation. Do that for all 4 of these tasks, whatever you come up with. And then task 2B is to look at the agains measure for the audio and orthographic word listeners. If these significant factors differ at all from the factors involved in your equation for task 1B, then let me know. Is there any difference between what you get here and here? This optional bonus task only applies to tasks 1A and B. Once you're done with tasks 2A and B, you don't have to do interpretive work on top of that, because the number of agains is not as important to the research question as the nativeness rating was for us. So we don't need to think about it that hard, but you can think about it a little bit as you try to kind of see what's going on here in terms of the independent factors that are having an effect on that dependent measure. Okay, to logistic regression, we have a different data set for this. This one also involves German. I went through like a phase in my life. What can I say? So the following data set comes from a continuous word recognition task, like the one we ran as a demo in class. This task involves listening to a long series of words and determining whether each word is new or a repeat of a word that has been presented earlier in the list. And I'll mention here, before I go too far, we didn't actually run this as a demo in class, but I kind of like showed it to you in the lecture. Yeah, so some of you have been in my 441 class, have seen this, and hopefully have done it yourself as well. But this is just, I think, yeah, as part of that logistic regression lecture, we saw how that sort of thing works and analyzed some data from it. Okay, so in this version of the study, listeners heard two separate lists of German words, one produced by female speakers and the other produced by male speakers. Both lists were 160 words long with 80 new items and 80 repeated items each. So like just to explain the kind of gender factor here, like if you're listening to a set of repeated words, and then all of a sudden some of the words are repeated in different voices. That's kind of even more obvious if you make the switch between female and male or vice versa. So we kept those two sets of speakers separate. And then, these are fairly long word lists as well. So that winds up being 320 trials for the whole experiment. That's a lot to think of anyways. But within those, half of those items are going to be new and half of them are going to be repeated. As in the class demo or the lecture demo, half of the repeated items were presented in the same voice as on the initial trial. The other half were presented in a different voice. The manipulation of interest in this experiment is that 3 different groups of listeners participated in the task. So again, there's going to be like group or listener or group differences in the data. There are, number 1, native speakers of German. This is the first field of data in this data set. So you might be a native speaker of German, or you might be a native speaker of English with some knowledge of German, like taking classes at university or something. And thirdly, native speakers of English with no knowledge of German. We probably know lots of people like that. But either way, we got all 3 groups to participate in this experiment. The listeners are coded in the first column in the data frame as either German, if they're a native German speaker, Eng Bai, if they are sort of bilingual. So English with some knowledge of German. I got those speakers down here. And then also Eng Mono down at the bottom, which are the monolingual speakers of English right here. Okay. The rest of the variables in this data frame are defined down below. A lot of these you won't have to worry about so much. So there's a unique number for each subject. There's the gender of the speaker on each trial. There's the trial number. There is the code for the talker who produced the word in the trial. That's right around here. There is the German word spoken by the talker on that trial. And I guess this is the point at which I should point out that these are going to be structured like the words that were spoken on for the first task. They're all C, consonant, vowel, consonant, 1-syllable words in German with some diphthongs in the middle here, like Baum and Deich and so on and so forth. But they kind of the idea here, mostly the research question is to see whether we kind of get that same sort of like repeated word effect if you're listening to words that are spoken in a language you don't know or don't know that well. Right, so that's why we're getting English listeners to hear these German words. There is Selleck's frequency data for German words as well. So that's these big numbers in here, like der is the word for the in German. So that's got a really big number, 217,704. Deich, not so much. I can't actually off the top of my head remember what Deich means. Yeah, like dough, I think. D-O-U-G-H. Anyways, like I said, it was a phase. So there's also a frequency bin, like we saw before, for high, mid, and low frequency words. So that'll come into play later. So yeah, one in this case, sorry, I just realized that's written wrong. So I'm going to fix that. Yeah, so high frequency is the big numbers. That's a 3, and then low frequency is the low numbers, so that's a 1, and then 2 is the mid frequency. So I'm glad I caught that. There's also timing information on this, which is not super great. This is before I really learned how to deal with timing information, but there's a computer timer that gets started when the trial is presented to the listeners, and then it ends at a later time. And then I come up, and the problem is the timer counts in 60ths of seconds, because that's how often electricity kind of goes in an alternating current to your computer. Like I said, it's not super sophisticated. But so anyways, it eventually gets converted into seconds, but they're basically in 60ths of seconds still. So yeah. Anyways, some sort of the really interesting information here is in between that information. So there's whether or not the word is a repeat, and there's also what the response is. So you have to say, like, if you hear a repeat, your job is to say whether it's a repeated word or not. So this one is new, and they're saying, well, no, it sounds like it's new. This one's a repeat, and this person says, yeah, it sounds like it's a repeat. So most of these they're getting right. Here's one where they get it wrong, so on and so forth. But that's what those numbers represent. So if it's a repeated word, that's a 1. If it's not, it's a 0. If it's the response is also 1 for repeats and then 0 for new responses. I told you about the time. Then there's a field for correct, whether or not they actually identified the repeat or new status of the word correctly. And for most of these are 1s. That means that they got it correct. Yeah, so maybe I should put that in here too. 0 for incorrect. It's kind of intuitive to me, but it might not be intuitive to you. There's also same talker. So if it's in the same talker's voice, that's a 1. We're kind of getting far afield here, but that's this field up here. So if it's the same talker as on the first presentation, it's a 1. If it's a different voice, it's a 0. Yeah. Right. And then there's also the number of trials between the initial and second presentations of a repeated word. That's kind of interesting. So that's kind of the idea that, if you haven't heard the word for a while in the experiment, then you might have forgotten it to some extent. And like I said, there are 320 trials in this experiment, 160 in each block. So you can go for quite a long time between hearing these words. So then there's also it's kind of bins for delays, right? So just taking this gradient measure delay and chopping it up into something more categorical. So that final field will give you a value of 1 for any words that's been repeated within the last 40 trials, 2 for anything within the last 80 trials, but from 41 up, and then the next 40 above that, and then the next 40 above that. So it's a little bit arbitrary, but it's kind of the easiest way to split it up into evenly sized groups. If it's a 0 at the tail end, that just means it's a new word altogether. And these are the numbers you get for the repeats. Same thing for that delay variable in general. Okay, so what do you have to do? That's, like I said, a lot of detail work in this one, but you don't have to worry about most of them. So for task 0, for this problem, we're only going to look at listener responses to the trials which are repetitions of earlier words, i.e. the value of the repeat variable is going to be 1. Therefore, filter out the new trials before beginning any of the analysis below. This is a simple task, but again, like I said, this is something you should know by now for this class. So just go ahead and get rid of these words which are new in the database. Task number 1, run a logistic regression to test whether the factors of same talker and listener L1 and their interactions have a significant effect on the number of correct responses to the repeat trials. So you've already filtered out the others, so basically what's left, you look at the factors of same talker and listener L1, and then your dependent measure is the number of correct responses that you're getting for those trials. If you find any significant effects or interactions, report the value of the estimate of the slope function in the logistic regression for that effect, along with the z-score and the p-value produced by the logistic regression significance test. This basically all comes out when you run the command, right? So just show to me that you know how to interpret it. And there's going to be some guidance in the lecture notes for that as well. Something which is a bit, make this kind of challenging and interesting for you, and also kind of flesh out what the results are telling you, is that for any significant main effects that this analysis yields, quantify the changes in the value of the logit function between the different levels of the significant factor. E.g., for a significant effect of same talker, compare the value of the logit function for the same talker trials versus the different talker trials. This step will serve as a sort of post-hoc analysis for the significant main effects you found. You don't need to do this for any significant interactions you get, however. It turns out this will take a little bit of time to do. It's just kind of a way to do sort of post-hoc analysis. But if you get an interaction, you're going to have to wind up breaking your data up into sort of multiple subsets or subsets by subset, and that's more than we need to do right now, so just don't worry about it for interactions, but do it for the significant main effects. And I had people do this for the first time 2 years ago, and everybody's like, what are you talking about? And so I kind of had to spell it out a little further. So to help you out with this part of the task, I'm including a specific example down below. Thanks. The easiest way to quantify the changes in the value of the logit function between the different levels of factor is to start with a contingency table of the number of correct and incorrect responses for the different levels of that factor. For example, we can look at how these numbers break down for the gender of the speaker, the words in the experiment. That turns out not to be significant. So basically, I want you to, if you're looking at the number of correct responses, so 1 is correct, 0 is incorrect. And then you're also breaking down the data by who spoke it, whether it was a female or a male, and that's kind of like two different groups of stimuli. But either way, we get these numbers. So the probability of a correct response for the female-produced stimuli is going to be this correct number, 3206, divided by the total number of stimuli they heard from female speakers, which is that sum, that plus that. And if you do that math, you get basically 77% or 0.771 if you want it to range from 0 to 1. And the probability of a correct response for the male-produced stimuli is this correct number divided by those two cells together, which is about the exact same number. So it's almost exactly the same, which is why this is not significant, but either way, it works as an example. So if you use those probabilities to calculate the logit function for the female-produced stimuli, you get a log odds ratio of 1.212. This goes to this. And you get a corresponding log odds ratio of 1.29 from this for the male-produced stimuli. And the difference between those scores is just 0.007. What do you know? 007. How coincidental is that? Anyways, that's all you need to tell me for each significant factor you find in this part of the exercise. So just, this shows you, in this case, that people do very slightly better on the male stimuli than they do on the female stimuli, but that's not significant. The reason you'll be running these is because you've kind of flesh out significant effects anyway. So at that point, you can say, oh, they're doing better on this level of the factor and then on that level of the factor. Okay, so task number 2 is looking at different kinds of explanatory factors. So one useful feature of logistic regressions is that they can not only accommodate multiple categorical variables as independent factors in the analysis, but they can also analyze multiple gradient variables as independent factors too. So that's fun. And it's kind of like running a linear regression on top of a logistic regression, sort of, or mixing the two. So for task 2, we're going to try out how this works by running the same analysis as you did for task 1, but adding frequency and delay as independent factors in the logistic regression. And these are these big numbers here, right? Which have lots of, range in them. The delay numbers are here. They can kind of range from 0 to 159, basically. Okay, so you should be testing, therefore, 4 different factors in this model, along with all their various potential interactions, which, generally speaking, is a bad idea. But since I've done this, hopefully the result won't be too overwhelming. But we're looking at same talker, listener L1 from task number 1. And then down here, we're also going to add frequency and delay. So those are your 4 factors. And then your dependent measure is going to be the same. It's just like whether people got the response correct or not. For this part, what I want you to look at is only any new significant effects that this analysis yields. So any effects you did not already find in task 1, which you already kind of know about from that. So for that, I want you to quantify the changes in the value of the logit function between the different levels of the significant factor. And just to make this explicit, I'll put new significant main effects that this analysis yields. So if you get any new significant interactions, then don't worry about them. You still shouldn't analyze them in this fashion. How about that? Okay, so for this part of the task, there's no easy way to generate numbers like this for a gradient measure like delay or frequency. So if you get significant effects for those factors, use the frequency bin and delay bin variables to kind of chunk up the data into smaller subsets when analyzing those potential effects. So I'll do this for frequency. If that turns out to be significant, you get a data set that looks like this. So remember, we have 3 different frequency bins here with low, medium, and high frequency. So, and then we have number of correct and incorrect responses for both of those, all 3 of those bins, right? So you just need to split them up like that, and then kind of follow the steps you used for the gender non-effect up here to just look at how much does the sort of logit value or logit value differ between like this column and this column, except in this case, we're going to be looking at like all 3 of the columns compared to each other, right? Okay, so for these 3 combinations of stimuli, yeah. Okay, right. 3 sets of stimuli. Sorry, I changed this from last time because, again, I don't want to blow anybody's mind away here. I just want you guys to understand what you're doing and to show me that you do understand what you're doing. So also note that the output of logistic regressions depends on which factors you test in the model. With that in mind, did any of the results of your analysis from task 1 change in the results of your analysis for task 2? If so, which ones? Lastly, once you crunch through all the number work above, take a moment to interpret the results you found, because that's why we're doing this. What do the significant effects you've discovered tell you? Does the same talk or different talker effect on repetition recognition accuracy still hold? I.e., normally people recognize a word as repeated better when they hear it produced by the same voice than produced by a different voice. And does the language of the listener have an effect on their performance on the task? Also, do you observe any effects of frequency or delay? That's kind of what part 2 is about. And if so, what do they show you? Okay, so this is kind of the main place the study started out with. There was that observation. We kind of expanded it with this. And then we also just for fun are going to play around with that possible effect as well. Yeah, so I'm actually going to pause here for a second and then talk about task number 3.